welcome back to Orbland's Tech.
In this video, I will go over my electrolyzer and tell you about the project it was really meant for.
This is my electrolyzer.
I talked about it in my last video, but in case you didn't see that, I'll link it in the description.
This here is a diagram of electrolysis, which is what my electrolyzer uses to produce oxyhydrogen gas. You can see that 2 volts are applied. These 2 electrodes go into the water conducts, the bonds are broken, and the gas flows up and out of the water. This is a very simplified equation showing how the electrons catalyze the reaction to split water into hydrogen and oxygen. This mixture is a very explosive mixture that reaches temperatures in excess of 2800 Celsius and burns at around 12 meters a second. So do not try this at home. Some technical specs for my machine. Power source is a desktop power supply giving 18 volts and a max of 10 amps. The 6 plates are made from 304 stainless steel and are 16 centimeters in diameter with 1 centimeter wide gaskets, giving about 153 centimeters squared of effective area per plate. The buffer tank up here prevents water from contaminating the system and from the electrolyzer pressure spiking. It is meant to be high pressure, so sealing is very important. As you can see, I have a lot of Teflon tape everywhere. I'm using 1/2 inch Teflon tape from Menards to seal the fittings, which are just 1/4 inch NPT push-to-connect fittings, as you can see here. The outlet tube has an inline pressure gauge, which has yet to rise above 1 bar. However, I have been able to fill some balloons as well as detonate them.
This is the CAD for the electrolyzer. You can see that I actually designed threads for the NPT fittings using an incredible feature script called ThreadLab, which allows you to create both custom and pre-modeled threads, both as actual models, cosmetic, or blank. For those unfamiliar with Onshape feature scripts, they are program features that can be added to your Onshape interface. They are made by both companies and individuals and cater to a variety of needs. Back to the design, I decided on 3/8 inch 1024 threaded rod for holding everything together, since I could cut the rod to arbitrary lengths. In the final assembled model, I used nylon lock nuts to make sure the seal wouldn't loosen, although I do have to disassemble the electrolyzer every time I use it to clean the plates. For the buffer tank, here, I use the same ThreadLab feature script for the end plates, as well as the same threaded rod, albeit in different.
For parts, I 3D printed all of the end plates in PLA+, just like most of my projects. For anyone wondering, I use Duramec filament from Amazon. It's good for strong and reliable filament and it's pretty low cost. My printer is an Anchormake M5C, which is a really good beginner printer. Not sponsored, I just like the printer. I initially printed them here with about 6 walls at about 25 to 50% infill, but they cracked and warped with the heat produced from the electrified plates. I reprinted all of the plates with more walls, and the larger ones were printed with more top and bottom layers, about 10 layers to resist warping. The body of the buffer tube here is made from 2mm thick aluminum tube from Amazon that I cut with my school's metal saw. You'll notice most of my parts are from Amazon, just because it's easy. To break that trend, threaded rod here, which is 1024, and the nuts here, which are nylon thread lock nuts, were bought from Home Depot. I bought about 5 3-foot rods that I cut with an angle grinder at my school. All of the off-the-shelf parts like the fittings and tubing are from Amazon too, as well as my trusty desktop power supply. For the gaskets, I used neoprene rubber. I bought a sheet from Amazon and cut it using my school's laser cutter. Here's an example piece that was cut with the laser cutter. There was a lot of trial and error, and in the end, it was still not easy to cut. To anyone wanting to cut rubber with a laser but has never done so before, slower is better than more power, and the more passes the better. As you can see, these edges are decently clean, but please cover the top of the rubber with masking tape, otherwise you'll have rubber ash everywhere, and the edges will be pretty darn rough. And it doesn't wash out the ash, and the smell is horrible. On to the plates. They were custom cut by Send Cut Send, a US-based fabrication company. They were pricey, but worth it. I used 304 stainless steel for the material and decided to post-process them myself, which meant sanding, a little deburring. So I did sand all the edges and faces, and I did the same for the aluminum tube. It was especially important for these plates because the faces need to have as much surface area as possible. And also, a especially smooth face will cause the gas bubbles to stick and not flow up and out into the buffer tube. This was not just a one-off gas maker. The high pressure gas was meant to fill this tank here through this one-way valve, pass through all of this plumbing, including this flashback arrestor, which is meant for welding torches, and this pressure gauge, and also pressure regulator, doubles. And then it was meant to pass out of this laminar flow nozzle. This was 3D printed and designed with some gas flow calculations, unlike the engine in my last video. Quick thing, I forgot to mention, this tube here is where I fill the electrolyzer. It's a small funnel, and then it uses a plug to replace the funnel so that gas doesn't leak out here. Before, I had a mechanism that had something like this, but it was attached up by the buffer tube, and water could pour straight into here, but I was getting some bubbling up, and I needed a plug, so I decided to go do away with all of that stand nonsense and just use a funnel and a plug. Just thought I'd mention.
That is satisfying.
I did make a version 1 of this electrolyzer a while back. It was designed to look like the Alex Labs hydrogen electrolyzer that he's using to power his Iron Man suit. However, sealing failed. As you can see, there's a lot of hot glue around the edges here. And I learned a lot from this, but I also used carbon steel plates, which oxidized almost immediately. Here's another image with the power supply. It only took 5 volts. It overheated past that. And here's some of the changes that I would have made if I made another one shaped like that.
So this has been an overview of my electrolyzer and what it was really meant for. If I ever test the max pressure and or get the lightsaber working, I will make a test video. I hope you enjoyed this video, and as always, any ideas for future projects, any advice, or regular comments would be greatly appreciated. And if anyone would like the files, parts links, and an assembly video, let me know. I'm considering the next video, I may be taking a second crack at designing a tricorder, because Star Trek is awesome, and the tricorder is practical. Kind of. Anyway, thank you so much for watching, and live long and prosper.